Program Ebelajau Additional Mathematics for 4, Chapter 5, Geometric Progression. So today, I am your teacher, Cikgu Wan Malina Abdullah from SMK Gajah Berang, Malacca. And today, I will teach you Chapter 5, Progressions. With the content standard, we will focus on 5.2, Geometric Progression. And here we have two learning standards. 5.2.1, identify a sequence as a geometric progression and provide justification. 5.2.2, derive the formula of the n term, Tn, of geometric progression and hence use the formula in various situations. Okay, let's start our lesson. Identifying geometric progression. There is a famous legend regarding the invention of chess related to series. According to the legend, a king from India wanted to meet the chess inventor to give recognition because this invention was interesting. The chess inventor only requested wheat to be given to him according to the following calculation. 1 grain of wheat in the first grid, 2 grains of wheat in the second grid, 4 grains of wheat in the third grid, and so on. Okay, you can refer at this diagram. Okay, at the first grid, okay, 1, and then after that the second grid becomes 4, and then the third grid becomes the first grid 1, okay, 2 grains of wheat, okay, at the second grid, and then 4, okay, at the third grid, and so on. Okay, when the chessboard was filled, okay, until the last grid here, okay, when the chessboard was filled, the total amount of grains given to the chess inventor was 1.84 times 10 to the power of 19, which is equivalent to 1.2 metric tons. The calculation of the amount of grains can be obtained by using geometric progression. Okay, to make it clear, okay, let's do inquiry 4. Okay, the aim to do this inquiry is to identify geometric progression. Okay, let's read the instruction. There are okay, now we read the situation first. The situation given here. There are various bacteria in our surroundings. Bacteria can be found on unhygienic food, human and animal intestine. Bacteria can reproduce very fast and lead to disease. Okay, such as diarrhea. Okay, the rate at which a bacterium reproduce. Okay, a bacterium reproduce is double. Okay, at the same rate, which is every 20 minutes. Okay, a bacterium will become 2. A bacterium will become 2, then 2 bacteria will become 4, and so on. Okay, if a human intestine has 2 million, until 2 million bacteria, he or she will be infected with diarrhea. Okay, and so mentioned here, if a human intestine has 2 million bacteria, he or she will be infected with diarrhea. Okay, now, number 2. Let's say if a type of food has only 1 bacterium, okay, we start with 1 bacterium. If you consume the food, estimate the time taken for you to be infected with diarrhea. Okay, when? Okay, estimate the time taken. Okay, the table below shows the number of bacteria reproduced. One box represents the reproduction of the bacteria in 20 minutes. Complete the table below until the number of bacteria leads to diarrhea. Okay, until the bacteria leads to diarrhea. Okay, just now we know that, okay, a human intestine will be infected with diarrhea when he or she has 2 million. Okay, 2 million bacteria. Okay, 2 million. So we try to complete this table, okay, until the number of bacteria reach at 2 million. Okay, we start with 1. Okay, after that 1 will become 2, then 2 becomes 4, 4 becomes 8, 8 becomes 16. Okay, 8 becomes 16, and we know that 16 is equal to 2 to the power of 4. Okay, and then 16 becomes 32. Okay, and we know here is 2 to the power of 5, and then here is 64. Okay, and then 1 to 8. Okay, 2, 5, 6. Okay, okay, here is 2 to the power of 5. Okay, here is 2 to the power of 5, 2 to the power of 6 here. Okay, to the power of 7, to the power of 8. Okay, and so on until you reach at 2 million. Okay, I tried already. We will reach at 2 million here at this part. Okay, 2 million 97,000 and 152 here. Okay, at this column. Okay, at this column. Okay, and this is equal to 2 to the power of 21 here. Okay, 2097 100 2,097,152. Okay, how long does it take for you to be infected with diarrhea? So how long? Okay, so just now we know that n is 21, so 21, okay, times 20 minutes. Okay, times 20, so this is equal to 420 minutes. Okay, it takes 420 minutes, okay, for he or she will be infected with diarrhea. Okay. And then determine the method to get the number of bacteria every 20 minutes from the previous 20 minutes. And is the value a constant? Yes. Okay, just now from 1 we produce with 2, and then 2 becomes 4, right? Okay, and then 4 becomes 8, and then 8 becomes 16. Okay, and then 16 becomes 32. Okay, after 20 minutes, okay, so ini times 2, okay, times 2, okay, times 2, and so on lah, times 2. Okay, so is the value a constant? Yes. Okay, here the constant value is 2. Okay, right, so that is geometric progression. Actually, from the result of inquiry 4, it is found that the ratio, okay, between any two consecutive terms is a fixed number. Just now we get 2. Okay, so the progression is called geometric progression. Okay, what is geometric progression? Okay, here geometric progression is a sequence of numbers where each term is obtained by multiplying a constant with the previous term. Okay. If T1, T2, T3, T4 and so on until Tn, okay, until the last term, okay, is the first n terms of a geometric progression, okay, the ratio of two consecutive terms is called the common ratio. Okay, we call as a common ratio and state, and we write as R. Okay, the common ratio is R. Okay, where R, how to get the common ratio from the geometric progression? Okay, we find the ratio between two consecutive terms. So R is equal to T2 over T1 or T3 over T2, or also can find by, okay, T4, okay, over T3, okay, and so on until Tn over Tn minus 1. Okay, and you cannot write like this. R is not equal to, you cannot find R T1 over T2, cannot. Okay, must T2 over T1. Okay, must divide by the previous term. Okay, alright. Okay, look at example 10. I'll give you one example here. Determine whether the progression below is a geometric progression. Okay, how to determine whether the given sequence number is a geometric progression or not? Okay, and then give your justification. Okay, look at A, example 10A. Okay. Okay. We know that the first term, okay, the first term is 5. Okay, the first term is 5, and remember that first term, okay, you can write as A or T1. Okay, so now from A we know that the first term is 5, so A equal to 5, and the find the common ratio, okay, for the progression. Okay, so still remember how to find the common ratio? R is equal to 15. Okay, divide by 5. Okay, then you get 3. Okay, try another one. Okay, you can find by R. Okay, for by finding the ratio 45. Okay, over 15. T3 over T2. Okay, this one T2 over T1. This one T3 over T2, and the answer is the same. R is 3. Okay, we try another, find another R. Okay, where R is equal to 135. Okay, divide by 45. Okay, you will get 3 also. Okay, R is 3. Okay, so now from here we know that, okay, when the value of R is the same, R is equal to 3, so this progression is a geometric progression. Okay, now let's try B. Okay, the first term is 0.1. Okay, 0.1, and we try to find R. Okay, we try to find R. R is equal to 0.2 divided by 0.1. So R is 0. Okay, sorry, R is, okay, so R is 2. Okay, 0.2 divided by 0.1 is 2. Okay, try another one. Okay, R equal to, okay, we try T3 over T2. So 0.3, okay, divide by 0.2. Okay, so 0.3 over 0.2 is 1.5. Okay, 1.5 or 3 over 2. Okay, so from here, okay, if you can see, the first R is 2, the second R is 1.5, okay, which is not same. Okay, so B, okay, B is not a geometric progression. Okay, A is a geometric progression, okay, but B is not a geometric, okay, not a geometric progression lah, okay, because R is not the same. Huh? Okay, next. Deriving the formula of the nth term of Tn of geometric progression. So how to derive the formula of nth term of geometric progression? Okay, let's do inquiry 5. Okay, the aim for inquiry 5 is to derive the formula of the nth term Tn of geometric progression. Okay, let's read the instruction. Number 1. Consider the geometric progression is, okay, 2, 6, 1854. Okay, given the geometric progression here with the first term A and the common ratio. Okay, discuss with your group's members and complete the table below. Okay, you try. You can try after this, but I will show to you. Okay. The first term, okay, with the given geometric progression, the first term is 2. Okay, so we know that this is A. Okay, this is A, the first term given. Yeah. Okay, the first term is A. Okay. Then the method to obtain the value of the term. Okay, how to get this term? Okay, you can write as 2 times 3 to the power of 1 minus 1. Okay, how we get 3? Actually, 3 here is the common ratio. Based on the geometric progression given here, okay, how to determine R? Okay, so we know that R is equal to 6 divided by 2. Okay, 6 divided by 2 is 3. Or 18 divided by 6. Okay, also you get 3. Okay, so R is 3. Okay, and then from here, okay, we know that the formula taken out here, okay, for the first term is A lah. We know that the first term is A. Okay, now look at the second term. Okay, the second term given is 6. Okay, 6. So how to get 6? Okay, how to get 6? You can write as 2 times 3 to the power of 2 minus 1. And this is equal to 2 times 3 to the power of 1. Okay, and the formula is AR, okay, or equals to AR to the power of n minus AR to the power of 2 minus 1. Okay, let's do the third term. Okay, the third term is 18. How to get 18? Okay, so we know that the first term is A, so 2 times 3. Okay, we can write 2 times 3 to the power of, this is the third term, so 3 minus 1. Okay, 3 minus 1 is 2. Okay, so this is equal to 2 times 3 to the power of 2. Okay, so 2 to the power of 3 to the power of 2. Okay, 3 to the power of 2 times 2 is 18. Okay, to get 18. And here we can write, okay, as AR to the power of 3 minus 1. Okay, we try the fourth term. How to get 54? okay, we can write 2 times 3 to the power of 4 minus 1. Okay, so this is 2 times 3 to the power of 3. Okay, and the formula is a r to the power of 4 minus 1. Okay, so from here, okay, to get the n term of geometric progression, okay, we can derive one formula here to get Tn. Okay, Tn. So if you can see here, the first term is a, the second term is a r to the power of 2 minus 1. Third term is a r to the power of 3 minus 1. The fourth term, a r to the power of 4 minus 1. Okay, the fifth term is a r to the power of 5 minus 1 and so on until Tn. Okay, so we can derive one formula where Tn is equal to a r to the power of n minus 1. Okay, so we will use this formula, okay, to find Tn. Okay, yeah. Okay, from the results of inquiry 5 just now, we can notice that the value of each term in this geometric progression can be obtained by using the formula below here. Okay, so we will use this formula to find Tn. Okay, the n term for geometric progression is Tn equal to a times r to the power of n minus 1. Okay, such that a, okay, this a is the first term, okay, and r is the common ratio. Okay, r is the common ratio and n is the number of the terms. Okay, let's see example 11. A, find the common ratio and the fifth term. Okay, find the common ratio and the fifth term of geometric progression. Okay, for this progression, 4, negative 20, 100, negative 500 and so on. Okay, A. Okay, A. From the progression, we know that the first term is 4. Okay, the first term is 4. Okay, and the common ratio are, okay, the common ratio is negative 20 divided by 4 is negative 5. Okay, so determine the value of A and R. Okay, the first term is 4. The common ratio is negative 5. Negative 5. Okay, so we already answer this question lah. The common ratio is negative 5. Okay, then how to find the fifth term? Okay, the fifth term, so T5 lah. Okay, just now we already know, we know that the formula to find Tn is ar to the power of n minus 1. So T5 is equal to a times r to the power of 5 minus 1. Okay, use the formula. So a is 4, substitute a here. Okay, a is 4. Okay, and r is negative 5, substitute here. Okay, so 4 times negative 5 to the power of 4. Okay, just use your calculator to find the answer. You get T5 is 2500. Okay, 2500. So that's the answer. Okay, now we try B. Okay, find the common ratio, find R, and the seventh term of geometric progression for this sequence number. Okay, so A is 2. Okay, we find A and R. Okay, how to find the common ratio? Okay, so common ratio is T2. T2 is 2 over 3. Okay, divide by 2. Or T3 divided by T2. Also can. So R is 2 over 3 divided by 2 is 1 over 3. Okay, just use your calculator. Okay, now we want to find 7 terms. So T7. Okay, T7 is equal to, now apply the formula. T7 is equal to A, R to the power of 7 minus 1. Okay, so this is equal to A is 2 times 1 over 3. Okay, 1 over 3 to the power of 6. Okay, directly use calculator to get the answer. Okay, so the last answer, the final answer is 2 over 7 to 9. Okay, that's the answer. Okay, that's the answer. Now, okay, let's try example 12. Find the number of terms of geometric progression. Okay, for this geometric progression, we know that A is negative 25 over 3. Okay, negative 25 over 3, and R is T2 over T1. T2 over T1. So 5 over 3. Okay, 5 over 3 divided by negative 25 over 3. Okay, and you will get R is negative 1 over 5. Okay, you will get this value. Okay, and from the geometric progression given, okay, the last term is 1 over 9375. Okay, so this is Tn. Okay, we want to find the number of terms of this geometric progression. Okay, how many terms for this GP? Okay, so let Tn, okay, we can let Tn is equal to 1 over 9375 lah. Okay, and apply the formula. Okay, we can write as 1 over 9, okay, 9375, okay, is equal to A. So A is negative 25 over 3. Okay, over 3. This is A times R. R is negative 1 over 5. Okay, to the power of n minus 1. Okay, and then I continue this side at this side, so we can write. You shift this value to this side, negative 25 over 3 to this side, so you will get 1 over, sorry, negative 1 over 78,125. Okay, 125 equal to negative 1 over 5 to the power of n minus 1. Okay, and after that we can change 78,125 to 5 to the power of 7. So we can write as like this. We can write like this: negative 1 over 5 to the power of 7. Okay, this is the same. Okay, 5 to the power of 7 is 78,125. Okay, and this is equal to negative 1 over 5 to the power of n minus 1. Okay, after that we can write like this: a negative 1 over 5 to the power of 7, and this is equal to negative 1 over 5 to the power of n minus 1. Okay. Now, if you can see here, this is the same. So, you can compare both sides. So, let 7, okay, you can write 7 is equal to n minus 1. Then, n is equal to 8. So the number of the terms for this GP is 8 terms. Okay, so 8 terms. Okay, now, okay, let's try example 13. Okay, an open stadium has 20 chairs in the first row. Okay, the number of chairs in the next row is 1.5 times the number of chairs of the previous row. A. Calculate the maximum number of chairs in the 10th row. Okay, A, we want to find T, 10. Okay, and then B, which row has at least 505 chairs? Okay, so we want to find which row, so that means we want to find N. Okay, now A, we do A first. Okay, we solve A first. Okay, from the given information here, the first row, so that is the first term. That is the first term, so A is 20. A is 20, and uh, R is 1.5. Okay, R is 1.5. Okay, because the number of chairs in the next row is 1.5 times the number of the previous row. So that is your R. Okay, then we can write the progression like this. 20. Okay, the first row, and then the R is 1.5, so the next row is 30 because 20 times 1.5 is 30. Okay, the third row is 45. Okay, the fourth row is, okay, you just multiply by 1.5 lah, and so on. Okay, so now we want to find the maximum number of chairs in the 10th row. Okay, in the 10th row, so that is T10. Just apply the formula. T10 is equal to A times R 1.5 to the power of 10 minus 1. So just apply, use calculator. 20 times 1.5 to the power of 9 is 768.9. Okay, which is this is equal to 768 chairs. Okay, so the maximum, we just take the maximum numbers is in the 10th row is 768 chairs. Okay, so B. Now let's solve B. Which row has at least 505 chairs? Okay, at which row? So we want to find N here. Okay, so let Tn, given that Tn is greater than or equal to 505. Why I use greater than or equal? Because of this term, at least. Okay, so Tn greater than or equal to 505. Apply the formula. So A times 1.5 to the power of n minus 1 is greater than or equal to 505. Then how to solve this? Just apply the previous lesson before. Okay, we use logarithms to find n. Okay, before that you can shift this 20 to this side. Okay, move to this side. Then you can write 1.5. Okay, 1.5 to the power of n minus 1 is greater than or equal to 5. Okay, 505 divided by 20. Okay, then to find n, okay, we apply logarithms. Okay, by taking log to the both sides, okay, you can write n minus 1 times log 1.5. Okay, you can write like this, greater than or equals to log 5 505. Okay, 505 divide by 20. Okay, just use your calculator. Okay, then move this log 1.5 to this side. So n minus 1 is greater than log 505 divided by 20. Log 505 over 20 divide by log 1.5 is 7.96 actually. Okay, you can try to press your calculator. Okay, then after that, okay, you just solve and you get n is equal n is greater than or equal to 8.96. Okay, 8.96. Then okay, we know that n is 9. N is equal to 9. Okay, fine. You must take the whole number. Okay, which is near to the minimum number. Okay, the minimum number from here, minimum whole number. Sorry. Okay, so n is equal to 9. Okay, that's all for today. Thank you.